everyone. I am your math teacher, Miss Arlene. Today, we will be dealing with the most essential learning competencies given by the Department of Education for Mathematics Grade 8. And so, for our first lesson, we will be discussing about factoring by the greatest common monomial factor. And before that, we need first to review about your prime factors and about the process of factoring, which is your prime factorization. And our objective for this topic is to illustrate factoring by the greatest common monomial factor. And so, are you ready to have a game? Alright, so we will call this game your fact or at.
Our game is entitled Fact or At. Our objective is to process prior knowledge, particularly on factors and prime factorization. We need to analyze the statements carefully. If the statement is correct, then we need to consider it a fact. Otherwise, we need to act by correcting the given statement. Number 1 statement. 5 is a prime number. Is it a fact or we need to act? Alright, the correct answer is fact. Job well done. Our second statement is there are 3 prime numbers from 1 to 10. Is it a fact or we need to act? Alright, so we need to act on it. Why? Very good. Why? Because the prime numbers from 1 to 10 are 2, 3, 5, and 7. So there are 4. For our next statement, the lowest prime number is 1. Is it a fact or we need to act? Alright, so we need to act on it. That's awesome. Why? Because 1 is not a prime number nor composite. It is a unit number. Let's proceed. 11 is a factor of 33. Is it a fact or we need to act? That's it. It's a fact. Very good. The factors of 12 are 1, 2, 3, 4, 6, and 12. Is it a fact or act? You're right. That again is a fact. Next, 20 can be expressed as 2 times 2 times 5. Fact or act? The correct answer is fact. You are the best. And for our last statement, the factors of 2x are 2x and the square of x. Is it a fact or an act? Very good. That's awesome. Now we need to explain it. 2x squared does not divide 2x evenly. Why? Because your 2x divided by 2x squared is equal to 1 over x, and the quotient is not a whole number, rather a fraction. Congratulations, that's it.
Did you enjoy the game? Of course, you had a lot of fun. Those topics, your prime factors and your prime factorization, are needed for you to better understand our lesson, which is on factoring by the greatest common monomial factor or your GCMF. So we consider this rectangle. Let's say the length of this rectangle is equal to x plus 3. And let's say the width is equal to 2. What do you think is the area? Very good. The area of this rectangle given by the formula length times width is equal to, let's just substitute the values for your length and your width. Your length is x plus 3 and your width is equal to 2. Since multiplication is commutative, we can write that one as the area is equal to 2 times x plus 3. If you can observe, your length and your width are the factors of your area. Now, the relationship of your 2 and your x plus 3 to your area. So, our area would be equal now to 2x plus 6 by your distributive property. So, we distribute 2, so that is 2 times x, each 2x. And then 2 times 3, that is equal to 6. The relationship now of your length and width to this area is that your length and width are factors of 2x plus 6. And so, we say that 2 is common to 2x and to 6. So that is how we illustrate your greatest common monomial factor. Before we continue in illustrating our factoring by your greatest common monomial factor, let's try to understand first a GCF. So our GCF means greatest common factor, right? And how do we factor again polynomials? That is by using your prime factorization. And to check that, let's have first an example. So say for example, we want to find the GCF of 4x cubed and 8x squared. So by prime factorization, we know that your 4x cubed is equal to 2 times 2 times x times x times x, right? Because 2 times 2 is 4 and x times x is equal to x cubed. The second monomial is 8x squared. So when we are going to factor that one, that is equal to 2 times 2 times another 2 times x times x. There you have it, ladies and gentlemen. So we have 2 times 2 times 2, that is equal to our our numerical coefficient, which is 8, and then x times x is equal to our literal coefficient, which is our x squared, or our variable. So how do we know the GCF? Okay, so how do we know the GCF? So first, we identify the common factors. So these are our common factors and your variables. So let's identify them. We have your 2 times 2 times x times x. Okay? So after we identify, then we now multiply the common factors. So we have 2 times 2 is 4 and x times x is equal to x squared. Therefore, we say that the GCF of 4x cubed and 8x squared is equal to 4x squared. Once again, let's review the steps. First, you need to factorize both monomials. The second one, you identify the common factors, and finally, you multiply your identified common factors. Okay? Another example. Say for example, we have 15y raised to the 6th power and 9z. So what would be the GCF? Again, going back, our first step is to prime factorize. So we have 15y raised to the 6th power is equal to 3 times 5 times y, another y, more y, and finally another y. And your 9z would be equal to 3 times 3 times z. Okay? The second step, once again, is to identify their common factors. So their common factors, we have only one common factor. So that is equal to 3. Since 5 and 3 are not common, and of course, it's obvious that y and z are not common variables. Okay, so this now is the GCF of 15y raised to the 6th power and your 9z. Are you ready now for our main topic? Yes, so we proceed to our next. That's it. We are now ready in illustrating or in factoring by the greatest common monomial factor. So example number 1. We are to factor your binomial 6x plus 3x squared. So how do we do that? First off, we need to identify the greatest common monomial factor. So how do we do that? So we need to factorize your terms. Your first term is 6x and your second term is 3x squared. So factoring this one, the prime factors for your 6x are 3 times 2 times x. Or since multiplication is commutative, you may write that one as 2 times 3 times x. And the prime factors of your 3x squared are 3 times x times x. The second one, the second step in your GCF, we identify the common factors. So we put it in the box. So we have this one now is your GCF. So the common factors are 3, bring it down, and then x. Now we consider this one the GCF or the common monomial factor of the two terms. Our next step in factoring, so this is our first step. That is to identify the CMF. And our second step, we are going to divide your CMF in both terms. Alright? So we have your 6x plus 3x squared divided by our CMF. So substituting the values now, we have 6x divided by our CMF is 3x plus 3x squared. And our CMF now is again 3x. So 6x divided by 3x, that is equal to 2. Very good. And then plus 3x squared divided by 3x is equal to x. Now for our step 3, this is our step 2. And for our step 3, we write now your CMF and this other factor as factors. So your final answer would be the CMF times the other factor. So in our first step, we obtained the CMF. In our second step, we obtained the other factor. And our last step would be the CMF. We write this now in factored form. So our CMF is 3x times the quantity, our other factor is 2x plus, or 2 plus x, I should say. So this now is our factored form. Now, how do we know if our answer is correct? We try to check this one. So by checking, we have your 3x times 2 plus x. We must obtain the same polynomial. Okay, so by your distribution property, we distribute your 3x to 2, so we have it 6x, right? And then you distribute your 3x to x, and so the answer is 3x squared. So you see, we obtained the same polynomial by checking. So that is our example number 1. For our second example, let's say you're going to factor your polynomial 12x cubed, y raised to the 5th power minus 20x raised to the 5th power y squared z. So again, for our step number 1, we're going to factorize, or we're going to find for the CMF. So we have your 12x cubed, y raised to the 5th power, and your negative 20x raised to the 5th power, y squared, and then z. So by factoring, the prime factors of your 12 are 3 times 4, or 3 times 2 times 2. Or you may interchange the position since multiplication is commutative. So 3 times 2 times 2, times x times x times x times y times y times y, another y, and finally a y. And then for the factors of your negative 20, we may write negative 5 times 2 times 2 times x, another x, 5 x's, and then times y, and then z. So for the CMF, we are going to identify the common factors. So we have your 2 and 2. So we have 2 times 2, your x, and another x. So we have x times x times x, and then y and y. So we have y times y. So your CMF now would be equal to 4x cubed, since there are 3 x's, and then y squared. Another technique for that is to identify first the GCF of the numbers. So if we are going to write it down, another way of solving that one, if we're going to write down the GCF of 12 and 20, so we have 12 and 20. The factors of 12 are 1, 2, 3, 4, 6, 12, right? And the factors of 20 are 1, 2, 4, 5, 10, and 20. If you come to think of it, their GCF is 4, and that now is the number here. And when you pertain to the variables, the variable with the least exponent, you consider the variable with the least exponent. So you are to choose between x cubed and x raised to the 5th power. So x cubed has the least exponent, so that is your x cubed here. And finally, your y raised to the 5th power and y squared. You need to choose between the two. The variable with the least exponent is of course y squared, so that is placed in here. And since z is not present in this monomial or in this term, then we cannot consider z a common factor. So that is another way of solving it. In our next example, we will be using that technique, and it's up to you which technique are you comfortable with. Okay, so we proceed. So this now is for our step 1, which is on finding the CMF. And for our step 2, we need now to get the other factor by dividing the two terms with our CMF. So copying, we have x cubed, y raised to the 5th power, minus 20, x raised to the 5th power, y squared, and then z. Divide both terms by the CMF, which is 4x cubed y squared and 4x cubed y squared. Therefore, dividing it, 12 divided by 4 is equal to 3. And then x cubed divided by x cubed, we can cancel that one now. And then y raised to the 5th power divided by y squared. By your law of a quotient, you need to subtract their exponents. So you copy the variable y or the base, and then 5 minus 2 is equal to 3. Minus 20 divided by 4 is equal to 5. And then x raised to the 5th power, and divided by x cubed is equal to x. Copy the base and then subtract their exponents, so we have squared. And then we cancel that out, so that is equal to z. Now, in step 2, we obtained our other factor. And for our step 3, we write now our final answer in factored form by copying the CMF. So we have 4x cubed y squared times the quantity, our other factor is 3y cubed minus 5x squared z. Now, we try to check whether our answer is correct. So 4 times 3, that is equal to 12. And then x cubed times y squared times y cubed is equal to x cubed y raised to the 5th power. And then 4 times negative 5 is equal to negative 20. And 4 times, x cubed y raised to the second power times x squared z is equal to x raised to the fifth power y squared z. In our first two examples, we obtained the CMF using a long method. This time, I will introduce another method. That is, so our first step is to find for the CMF. So that is, we consider the numerical coefficients of the three terms first. Okay, so we consider 12, the numerical coefficient of 12x cubed, and 8. Actually, the numerical coefficient of the second term is negative 8. But then, since negative is not common to your first term and your last term, we can consider your positive 8. And for the coefficient of the last term is 24. We list down all the factors of the numerical coefficients. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Because these numbers divide the given number evenly without any remainders. And your 8, the factors of 8 are 1, 2, 4, and 8. Finally, the factors of your 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Actually, the common factors are 1, 2, and 4. But in here, we are considering your greatest common monomial factor. And the greatest common monomial factor is 4. So this now is your greatest common monomial factor. For the CMF, Ma'am, what will I do with the variables? Alright. For the variables, you identify the variable that is common to all the terms in the polynomial. So in here, y is not considered as a common factor because y is not present in your first term and in your last term. So we only consider x, but this time we consider the least exponent. So we are going to choose between your x cubed and your x. So, of course, your answer here is xy because your x has the least exponent, and that is 1. Therefore, we say that 4x is also the common monomial factor of the three terms of the polynomial. For the second step, we are going to find for the other factor. Again, how do we find the other factor? That is by dividing all the terms. 12x cubed divided by the CMF 4x minus 8xy divided by the CMF 4x. And then finally, 24x divided by the CMF 4x. So 12 divided by 4 is equal to 3. X cubed divided by x. By your law of a quotient, you copy the base and then subtract the exponents. So 3 minus 1, that is 2. And then minus negative 8 divided by 4, that is equal to negative 2. Cancel that out and so you have y. And then finally, 24 divided by 4, that is equal to or CMF and the other factor as products. So 4x times the quantity 3x squared minus 2. So that is our example number 3. For our last example, we consider this polynomial. Negative 28x cubed z squared minus 14x squared y cubed. So first step is to determine the CMF. So we consider 28 and 14. Knowing that the factors of 28 are 1, 2, 4, 7, 14, and 28. And finally, the factors of 14 are 1, 2, 7, and 14. If you come to think of it, the common factors are 1, 2, 7, and 14. but we need the GCF, which is 14. So, the CMF now for the numerical coefficients is 14. And for the literal coefficients, we have your x cubed, z squared, and your x squared, y cubed. So in here, we're going to consider the variable that is common only to both the terms. So as you can see, z is not present in here. So z cannot be considered a common factor. So with your y, only x is considered a common factor. But this time, we consider the least exponent of x. So that is 2. But as you also notice, there is a negative sign to both the terms. So we also consider negative as one of the common factors. Therefore, the CMF now is negative 14x squared. And for our step number 2, we are going to divide both the terms by the CMF. So we have negative 28x cubed z squared divided by negative 14x squared minus 14x squared y cubed divided by negative 14x squared. Negative divided by negative is positive, or we may simply cancel that one. 28 divided by 14 is equal to 2. X cubed divided by x squared, you subtract their exponents, copy the base, and then 3 minus 2 is equal to 1, or you may not write 1. And then copy z squared. Negative divided by negative is positive. And then 14 divided by 14 is 1. Since 1 is an understood coefficient, you may not write it. So we cancel now x squared and x squared, so we only have y cubed left. This one now is the other factor. And for our last step, we write your CMF and the other factor as products. So we have negative 14x squared times 2x z squared plus y cubed. When we try to check that one, we multiply it by distributive. So we distribute negative 14x squared times 2x z squared, that is equal to negative 28x cubed z squared. And negative times positive is negative. 14 times 1 is 14. And x squared times y cubed is x squared y cubed. So those are your examples on how to factor by the greatest common monomial factor. Thank you for listening, and let me remind you that you are a factor for you to understand your lesson. You are a factor because you are, number 1, you are letter F, you are friendly. As they say, people may forget what you have said, but they will never forget how you made them feel. And for the other meanings of the other letters here, you need to watch more factoring techniques in my next video.